functions. So in other words, one will increase something, one will decrease something. There are others that have a sympathetic output but not a parasympathetic. And we'll be looking at all of those. We'll be looking at the innervations with this. The signals coming from the parasympathetic, as we said the other day, tend to have fairly long preganglionic axons and fairly short postganglionic axons. I'll blow up pieces. That's just not detailed enough for us to see. And we can see cranial nerve 3 here coming on out, fibers from cranial nerve 3 coming on out, synapsing in the ciliary ganglion, and then headed to targets within the eye. We'll talk about these targets in more detail in a while. Ciliary ganglion, the pterygopalatine ganglion, the submandibular ganglion, the otic ganglion. These are 4 ganglia in the head that really have very important autonomic functions. These are the 4 ganglia that are noticeably separated from the target. As we continue on down here, we look at the heart here, all right? The sympathetic, the parasympathetic as well as the sympathetic innervation is of the 2 major nuclei that are involved with controlling your heart rate. So we have the SA node and the AV node. Those are the two nuclear masses in the heart innervations. With the lung, the innervation to the lung is basically in inspiration centers surrounding the bronchi that are in the lung, going deeper within the lung, but they help you to inspire, to respire, to take breaths in. So it's interesting what's going on. I want you to notice though, this is all pretty straightforward, okay? Preganglionic, postganglionic, pre-post, pre-post, pre-post. But down here we come down and have a plexus. Plexes are always really hard to really explain. They're hard to understand. These autonomic plexes are completely different from the nerve plexes we're going to talk about next week. Completely different. These essentially have, as you look at this, you're going, this is only one nerve. Why does this plexus exist? And that's a good question. What nerve, this nerve, what nerve is this? It's the vagus. It's the main component of the parasympathetic nervous system. Now, if I'm innervating all of these different targets, something you have to ask yourself is, oh, wait a minute. I have the innervation going to the heart. I have the innervation going to the lung. I have the innervation going to the digestive system. We're coffee sneezy sort of here tonight. The signals going there, while they are, in essence, very general signals, they're coming from specific fiber, for specific nuclei within the actual nuclear center of the 10th cranial nerve. So we look at this, and I know when I was learning this, I wanted to learn this as well. This is an axon coming down. No, it's not. It's a whole bundle of axons coming down, and some of them head off this way, and some of them come down and head that way. They go, why? Doesn't make any sense. You have to kind of turn the clock back. And the clock that you have to turn back is the developmental clock in this individual, where these fibers are coming out, and growth is happening. Those fibers are coming out very early in development. The heart's moving, things are moving, things are rotating. You remember what the heart muscle is going to move, twist and everything. Oh, maybe that's contributing to this, the development of the lungs. The lungs start out as very tiny little mass of cells that we're going to send this innervation to. I wouldn't try to understand a plexus in an adult, okay? At least these. These all, they start with one nerve, more or less. Trying to dissect them out and interpret them independently or independent branches is beyond anything we're going to do. What you should be aware of is that we have this cardiopulmonary plexus, okay? I know here, this particular figure is trying to divide it up into a cardiac plexus and a pulmonary plexus. Cardiopulmonary plexus, all right? Branches off of the vagus, innervates the heart and the lungs. We continue on down. This monster, this celiac plexus, is going to innervate the liver and the gallbladder. We're going to innervate the stomach. We're going to innervate the pancreas. We are going to innervate the small intestine and the ascending and transverse large intestine or colon. There's a lot happening here. So the vagus is anything but vague. It's very specific. It's got these specific targets. Everything in here coming off this for our purposes is essentially all the celiac plexus. Okay? So we're innervating everything here. We then have the spinal nerve roots coming off the sacrum that are going to form the splanchnic nerves. We have this inferior hypogastric plexus. This is a very simple plexus. It's more of a branching. These branches come together, they form a common nerve for a while, and then they once again shoot out. Here we have the sigmoid colon, we have the rectum. Then we have the bladder, and either the uterus and ovaries or a penis. So now we have all of this innervation to this tremendous variety of organs. We've got mostly glands in your head and regions of your eye. Okay, we're going to look at that reflex and what's involved with that. But other than that, we're mostly glandular in the head region. We have ganglia that are obvious. So if you dissect a head and face, you can actually locate all of the ganglia. But now the vagus comes along, innervates cardiovascular system and the digestive system. We have a lot of branching occurring. We have two major sets of plexes, cardiopulmonary and the celiac. Cardiopulmonary to the heart and lungs, celiac, digestive organs. Get down to the sacral, spinal nerves, and we have the parasympathetic signals going to the lower digestive organs, the sigmoid colon and the rectum, to the bladder and to the reproductive organs. Bang, that's it in a nutshell. Okay? Now, the parasympathetic innervations are pretty simple. The sympathetic are much more complicated, much more interesting, really. We're going to look at a schematic that shows you the cord and the signals coming out. And then we're going to look at this, the sympathetic chain or the sympathetic chain ganglia. These lie to either side of the cell bodies of the vertebra. Signals are going to be coming out. We're going to get into these. And those signals are then going to go on and do other things. You'll notice, here are the spinal nerves coming out, okay, from the cord. The spinal nerves then have two sets of connections to the sympathetic chain. These rami but divided up by color. A gray ramus and a white ramus. Oh boy, gray and white. What does that remind you of? Gray matter and white matter. Myelination and non-myelination. Oh, okay, sympathetic. I get the signal. So I have this. This ganglion, right? What do we call this axon? Preganglionic. Is it myelinated? It is. Which one is this? Postganglionic. Is it myelinated? No. Which one is white? Now, the gray ramus and the white ramus, all of a sudden is telling you information. The white ramus has preganglionic axons in it from the cord. The gray ramus has postganglionic axons that are leaving the chain and going out. Huh. That's cool when the name actually helps. Not too many times in anatomy that the name helps this much. Oh, this is so crazy. This is wild. This is different. So we have all of those thoracic roots. We have some lumbar roots. And they're going to do one of three things. One, they're going to come out and they're going to synapse in the chain ganglion. So that synaptic ganglion is in the chain. Two, they are going to pass through one of these ganglia and go to one of the abdominal ganglia, where they synapse and go to the target. Three, one of these is going to come out, pass through a ganglion, pass through one ganglion, pass through another ganglion, keep on going, and innervate the adrenal medulla. What you should remember from the other day is that sympathetic innervation of the adrenal medulla is a preganglionic axon synapsing at the target. Everything else in here is postganglionic. We okay with all that? So, the signal getting to the adrenal medulla, the sympathetic signal, is a preganglionic signal. The signal that gets to every other target is postganglionic. There has been a synapse. I'm going to blow up bits and pieces of this. We're going to look at it in the same way. Is that okay? That covered? Great. So let's look at the signals that are most superior coming off of the sympathetic chain. So here are all of these white rami. They're coming in. Signals are coming in from the cord to the sympathetic chain. All of these signals, well, these superior ganglia, signals come in and move up. There's a lot of movement in the sympathetic chain. A lot of signals move up and down. The most superior ganglion, okay? Superior cervical ganglion, here. Signals go to the head region, go to the eye, go to the lacrimal gland, the nasal mucosa. Signals go to the skin. There are no parasympathetic signals to the skin.